Now we completed Coulomb's law. The force between two charges are given by Coulomb's law. Force between two charges is directly proportional to the product of the charges and inversely proportional to the square of the distance. Now we completed the Coulomb's law. But to make the idea clear, let us do a problem. Force between two charges depends on the magnitude of the charges, then distance between the charges and the medium between the charges. By doing this problem, we'll have a better idea. Now there are two charges, Q1 and Q2. First let us see with the 2 microcoulomb and 3 microcoulomb. First charge is 2 microcoulomb, second charge is 3 microcoulomb, and the distance between them is 1 meter. And medium between that is air. So force experienced by the second charge because of the first charge is given by this formula, and here it is unit vector R12 cap. Here both are positive. First charge is also positive, second charge also positive. So positive, positive, there will be a repulsion. So the force experienced by the second charge will be towards the positive x-axis. Positive, positive. This is also positive. This is also positive. Positive, positive. There will be a repulsion. So the force is along the positive x-axis. So that's why the force is from the first charge to second charge. So it is I cap. R12 cap can be written as I cap. So instead of this R12 cap, you can write I cap. Then the value of 1 by 4 pi epsilon 0 is 9 into 10 raised to 9. Then first charge is 2 into 10 raised to minus 6. Second charge Q2 is 3 into 10 raised to minus 6. And the distance between them is 1 meter. So R square, so 1 square. Then this calculation can be done very easily. 9 into 2, 18. 18 into 3 is 54. Then the powers. Minus 6, minus 12. So 9 minus 12 is minus 3. Then be careful to write the unit. Force, the unit is Newton. And force is a vector quantity to denote the direction I cap. It's I cap because the force is along the positive x-axis. I cap is a unit vector along the positive x-axis. Now we will see the importance of Newton's law in electricity. See, this is the force experienced by the first charge. This is the force experienced by first charge because of the second charge. So it is equal but opposite. According to Newton's third law, for every action there is an equal and opposite reaction. Now this is the force experienced by the first charge because of the second charge. Magnitude is same, only the direction is different, it is opposite. Positive, positive. So force experienced by the first charge is along the negative x-axis. Positive, positive repulsion, it will be along the negative x-axis. That is why instead of I cap now minus I cap. So the magnitude is same, only the direction is different. This is along the positive x-axis. This is along the negative x-axis. Now we will see another situation with the second charge negative. Same 3 microcoulomb but negative. Now in this expression when we substitute Q1 same 2 into 10 raised to minus 6, only for Q2 we have to write minus 3 into 10 raised to minus 6. Then it is I vector. I vector is a unit vector along the positive x-axis. Since there is a negative sign, it will be force will be acting along the negative x-axis because here charge is negative. This I vector is a unit vector along the positive x-axis, but here already there is a negative sign, so the force will be directed towards the negative x-axis. Now force experienced by second charge because of the first charge will be equal to the negative of the force experienced by the first charge because of the second charge. So we have to change the sign of this minus I cap. So minus into minus plus. So 54. Force experienced by the first charge will be along the positive x-axis. This is the force experienced by second charge because of the first charge. Since it is a negative sign, it will be directed towards the negative x-axis. For the previous case, this charge is experiencing forcing along the positive x-axis. Now since it is negative, it is experiencing force along the negative x-axis, and this is experiencing a force along the positive x-axis. Only direction changes, but the magnitude same. In the previous case, this was positive and this was negative. Now this is negative and this is positive. Force between the charges depends also on the medium between the charges. To know that, we will see another situation. Same charges, 2 microcoulomb, first charge, second charge minus 3 microcoulomb. But now the medium in between the charges is water. Water relative permittivity. Water relative permittivity is 80. Epsilon can be written as epsilon 0 into epsilon r. Epsilon is the permittivity of the medium. Epsilon 0 is the permittivity of free space. Free space means air or vacuum. Epsilon r is 80. When the same charges are kept in water, the force is given by this relation. Instead of epsilon 0, epsilon. So instead of this epsilon 0, now we have to write epsilon. So 1 by 4 pi epsilon. For this epsilon, we can write epsilon 0 into epsilon r. But already we know the value for 1 by 4 pi epsilon 0, that is 9 into 10 raised to 9. So that is to be divided by 80. The same expression you have to divide by 80. So magnitude of the force changes. This is to be divided by 80. So now force is 0.675 into 10 raised to minus 3. Now force is reduced. Then this is the force experienced by the first charge because of the second charge. That is equal and opposite. Here it is negative, but here it is positive. So there is no change in the direction. The direction is same as the previous sum, but the magnitude changes because now we have kept water in between the charges. So the force is now reduced from 54 into 10 raised to minus 3. Now it is reduced to 0.675 into 10 raised to minus 3 Newton.